In theory, to move the VLANs from one switch to another, it would take a cable for each VLAN created between the two switches. The more VLAN there are, the more physical cables there will be between the two switches. In this case, the ports used to make the liaison between switches cannot be used for users. Here we have 3 VLANs, and therefore 6 ports between switches, which are used just to pass the VLANs from one switch to another. To avoid wasting resources unnecessarily on the switch, we will use a trunk link to pass several VLAN on a single link. The trunk can carry frames of different VLAN. Every frame that passes on this link is tagged by a number, which simply corresponds to its VLAN number. It's like a label that you stick to the package to find out which group it belongs to. On networks where there are several VLANs and several interconnected switches, you should always use a trunk link between the switches. The trunk marks the VLAN on the head of the package before sending it on the other switch. It allows switches to circulate frames of several VLAN on a single physical link. For example, on the diagram with the trunk link, if the left switch receives a broadcast that comes from the port fast Ethernet 01, part of the green VLAN, and the right switch also contains green VLAN, then it will have to tag the frame and send it to the trunk to transmit it to all ports that are also part of the green VLAN. Here's a normal Ethernet frame. And here's a modified Ethernet frame that's also called an 802.1q frame. The trunk inserts a tag field to the head of the original frame that allows the VLAN ID to be placed. The new header always contains the original source and destination MAC addresses. As the original header has been modified, encapsulation 802.1q requires recalculating the original FCS field into the Ethernet frame, as its content is based on the entire frame. The FCS field can detect if errors have crept into the frame during its journey. We will now see the configuration of a trunk. In order to circulate VLAN on the same link, it is necessary to configure a trunk between the two switches. The configuration must be the same between the two switches. The configure terminal command allows you to enter the overall configuration mode. The interface command allows you to enter the configuration of the interface you want to set. Here it is port 48, both on switch 1 and 2. And all that remains is to make a switch port mode trunk on both sides of the link. That's all there is to it. The command you see just below is optional. It allows one to define the native VLAN on 99, because by default, on all switches, the native VLAN is 1. Some frames that circulate on a trunk are not tagged, so you have to put them somewhere. This is where the native VLAN comes in. This is the VLAN in which the untagged frames are conveyed. So if a switch receives on a trunk interface a standard Ethernet frame, which is not modified, it will place it in this native VLAN. It's kind of like a VLAN by default. On Cisco equipment, some protocols, such as CDP or DTP, are conveyed in untagged frames and therefore in the native VLAN. CDP allows you to discover these neighbors, and DTP manages the automatic negotiation of the trunk. It's enabled by default. To return to the trunk configuration, you have to make sure that on the other side the configuration is the same. And the commands show interfaces switch port and Show Interfaces Trunk allow one to display detailed parameters of the trunk and information about the VLANs.